You're not typically dealing with clean data as in research. You're not dealing with well-written spell check queries. You're dealing with messy real data, PDFs, Word documents, HTML. And so far, we had to hand build the pipelines to extract the text, clean it, bring it in a format that's workable. But often we were actually restricted to workable because you could never cover all the edge cases of how the data is actually represented. And today we are looking at a way that could make all of that redundant by helping AI look at documents like we humans do. This is Nikolai. I run an AI agency and am the CTO at a generative AI startup. Today we are back continuing our series on search and especially on embeddings. Today we are learning from Jo Bergum. Jo is the chief scientist of Vespa and at the moment one of the chief evangelists of ColPali, and he's working on making it practical for production. We talk about how ColPali works, how to fine-tune it, and how to apply it to your use cases. This is actually a rebang of an episode, so let's do it.
This frustrates me a little bit is whenever I tweet about some language model or some development, or people will come at me and say, yeah, but I tried this and it's shit. So when you're working on search systems, you know that we won't get every query perfect, right? So we have this more like a probabilistic system, which might not respond in the way you were thinking that it would respond. So you think the response is shit, but when we're evaluating search system, we're looking like over a broad set of queries. Are we doing better for those? Maybe we are doing worse for some. There's this differentiation between head queries that are frequent, tail queries that are less frequent, and somewhere in the middle, the torso. And this frustrates me a little bit when people come at me and say, yeah, but I tried this model, it doesn't work for this case and that case. And that's also when I talk to practitioners that are actually being in this industry in search or working on machine learning systems and so forth. They are more excited, right, on the recent developments because they know that, yeah, they don't work perfectly, but you can fit them into some workflow. We can do more now than just 3 years ago, or just 2 years ago, or just 1 year ago. So there's definitely progress, but people are somehow that are not used to this or have this kind of ML background. I think they expect these systems to be 100% from the get-go.
Yep.
And you're not going to get that. That's also one thing when I look at retrieval. I think also that's also a little bit of the frustration from people coming into now the retrieval space and search space is that they're expecting more that the system will be perfect from the get-go, and then they'll start looking for different methods. Oh, I tried this method, I read about it on Twitter, and I'm trying retrieval, I'm trying vectors, I'm trying Colbert, I'm trying this other. So they're running around trying these different methods, but they haven't got the kind of basic evaluation methodology or mind of thinking. Yeah.
Yeah. And I think that's like a good prelude, basically, like the user perception and what you're building and that you're trying to basically map this together. Can you maybe go into like why do we actually want to map data, especially into like dense representation or in general, like representations that's numeric?
Yeah, there's a great paper from Ginny Lin on conceptual framework for why we want to have a representational approach in information retrieval. So the idea is that in a retrieval system, you have some kind of collection of documents that you want to search through and retrieve information from. And you have a user with an information need, and the user expresses this information need. Then we can have the system essentially interact with each of these documents in the collection. If you have some kind of magic model, let's say, that can estimate if this document is relevant for this query, then we can basically iterate over all the documents in the collection, invoke this model, and the model can say if it's relevant for the query or not. And we can do this for all of the documents. But the problem, of course, is that this is rather compute intensive if you want to build a system that is responsive and that maybe also have a low cost. For instance, at Google scale, they cannot spend a lot of compute per query because they have a lot of documents. And this is where you turn to a representational approach so that you can map the query text and the document into some kind of representation, matching with a similarity metric that you can perform a search in a sublinear time, meaning that you don't have to consider every single document in the collection to invoke this kind of magical model. So that's the whole premise of the representational approach. So there's a lot of words to describe like what most people would think like Elasticsearch. Oh, I need search. I'm gonna go with Elasticsearch. Gonna index my documents. They will tokenize it, invert it, and so forth. But that's one type of representation. Then you have a vector database. Oh, they're dealing with a dense vector representation. They're dealing with vectors. So I input my vector, but they're all representational approach. And the idea is that you can do this to scale the system so that make it cheaper. And he also touches on in the paper supervised representations versus unsupervised representations. And basically if the representation is learned or not. And if you look at the text embedding models that people are maybe familiar with, OpenAI, Ada, and so forth, they've been taking text and documents and inputting it through a transformer-based model or some kind of model, and then they learn these representation from relevance data, where you have like this for this particular query, this document is relevant. For this particular document, this document is, but it's irrelevant. And using that training data, you learn representations and you learn how to map these queries and documents into this vector space so that the relevant documents are closer in this space and the irrelevant documents are farther away. You can do this also with sparse representations, like we've seen a model called Splade, which also uses a transformer model, learns representation, but instead of having a dense representation where all the dimensions have a value, they essentially cut out a lot of the dimensions and they have a sparse representation. And yeah, there are a lot of variants around this, but if you compare it with BM25, for example, which is also a text scoring or representation, you don't have a learned representation because it's in one way it has a learned representation because it has seen all the documents, it knows all the words in the collection, it knows the kind of frequency, so it's more like a statistical analysis of your corpus. And but we still, since it has very few hyperparameters, we call it like an unsupervised method. So I really recommend reading that paper because I think it's a good, very good overview and also setting like vector databases versus search engines versus whatever in context.
Yeah, and especially the separation between the physical retrieval model and like the logical scoring model, which basically gives you like these like this nice 2x2 on dense or sparse and supervised and unsupervised. Do you think the dense unsupervised area is a little bit underexplored at the moment?
Dense unsupervised, in one way, a lot of so they've been trained on some generic data like MS Marco, which is this huge relevancy data set from Bing. So there aren't that many available data sets to train these type of models. Most of the ones that you find on Hugging Face have been trained on this data set. And you can generate data synthetically, or if you have data internally, like what you're building, you can also train your own text embedding models. But I think most people actually use them off the shelf and then hoping that the learned representation from MS Marco will work for their particular search use case. And even they're getting better and better, these embedding models, they still might struggle what I call in the out of domain setting, meaning that it might not be your use case for search or retrieval might not match with what they were trained on. And
Yeah.
there's a paper or a benchmark called Beer, the Beer benchmark. I'm sure you touched on this, which is a collection of different data sets where you can evaluate models that are like generic, unsupervised models and apply them to Beer and then see how they perform. And in the first rounds, I think the models that will represent text as a single vector, as a regular text embedding model, they were actually underperforming like the traditional baseline of BM25. In a lot of my work around search and retrieval, when I'm writing about this, I try to include the baseline. And BM25 is actually a pretty good baseline to what's the minimum you can do when you're building a search product. I would say, okay, let's start with the baseline, and baseline is BM25. Yeah.
And when you look at especially like the current paradigm of search, which is more like the extract, chunk, and embed, what is in the dense representation? What is the information that gets lost? Why is still a fine tuning of the embedding models might be necessary?
Yeah, I think it's actually on a maybe on a little bit higher level than that. Is that so? What are the documents that you actually want to make searchable? Are they like text documents? Are they PDF documents? Like, does the layout really of the documents really impact if a user is actually looking at some result for a query and is actually looking at that file using his eyes? Then things like where is the text centered on the page might impact if you find this document relevant or not. And if it has a figure or signs or graphics, that also might change our perception of if this document is relevant, in addition to the context that the user is and so forth. But if you look at just text, like if you already have somehow magically converted everything into some clean kind of text, then of course, how you actually go through this data and in the chunk and embed, of course, this is going to impact the representations because in a regular text embedding model, is that you run it through encoder style transformer model, which actually on the output layer outputs one vector representation per input token. So it's actually not one vector, but it's a vector per token or word. And then the text embedding models basically takes a pooling operation or an aggregation operation to represent this as a single vector. And the historical reason for we're doing it is that the transformer or the encoder models like BERT, they have a length limitation of how long they can actually accept. But not only that, I think it's very difficult to have a good representation for high precision oriented search when you are basically averaging all the vectors into one vector, right? Imagining a very long text, how do you actually summarize that text by just averaging all the words in that text? So, and that's also what we see with other types of models that learns representations like Colbert, that learns representations per word instead of trying to learn a representation for the full text. Yeah.
Yeah, and the what is the I think like one interesting part of the paper was also the quality, cost, space, and time trade-off dimension. Can you maybe explain like the dimensions and give one or two examples like where different models or approaches fall?
Yeah, I think this is a huge topic, right? But if you look at the representational approaches first, the things that tries to map things into representation, that you can have some similarity function where you can do at least the kind of candidate retrieval phase. They're, of course, using a single vector representation per document is beneficial, right? Because then when you're doing a search, you only need to do a rather simplistic dot product or a cosine similarity, which on today's computers or GPUs or whatnot, it is pretty fast. Then you have models like Colbert, which retains a vector per word, and then you have more complexity, right? So you have both storage complexity, compute complexity, and so those are like the representational approaches. I skip Splay now in the sparse representation. It's also a possibility to accelerate that. And then you can also accelerate it using various approximate nearest neighbor search algorithms and so forth. Then you have cross encoders, and the huge difference is that they are inputting both the query tokens and the document tokens or the feature data in general into one model at the same time. So those are typically deployed as re-rankers. So you already had a candidate retrieval phase, and then you're re-ranking them, and then you have full interaction. And because of the way, if you're talking in the transformer model context, they are quadratic with the input length. So when you're inputting the full sequence of both the query and the document at the same time, you have more compute than when you're doing it separately, as you do with Colbert or you're doing with a regular text embedding model. But it's a huge discussion. I think in one way, one thing that frustrates me is that when people talk about this thing, they talk about speed and latency. Um, is it fast enough? And the thing with search systems is that you can parallelize a lot of the work so that you, for instance, in the CPU architecture, when you're doing retrieval and ranking, you can actually shard this work over multiple CPU cores so you can get the latency down. That doesn't mean that the cost is actually decreasing, right? Because you're increasing the cost, you're using more resources. If I'm asking someone to paint my house and they say it's going to take, one company says it's going to take 1 day, and the other company is going to say it's going to take 4 days. But if I then look at the latency, right? Because the company that says it can do it in a day, they can throw 10 people at it, right? But it's going to cost me more in terms of money than the other company that might use fewer resources. So I think our human perceptions of latency is that we think about speed, how fast we can run. We're not used to thinking about that the workload can actually be parallelized. So that's one of the things that frustrates me a little bit when I get questioned. Can it be fast? And yeah, a lot of these things can be fast, right? So when you look at, you're searching in Google, you're searching and spending actually quite a lot of compute, but it's fast because they parallelize everything.
Yeah, and I think like most people don't really think in terms of trade-offs, but rather binary. And you have
Yeah,
to think about like your application, like what are you optimizing for? And
exactly.
this optimization will come at a cost of something else. If you're going for more quality and at the same time speed,
Yeah,
you will have more cost and likely also more space.
yeah.
Um, and do you think that the like different representations, how do you think about them? Do you think about them like in terms of like different search signals as well?
I think in the discussion of these different dimensions that you're thinking about, and especially if you're new to this field and you're trying to build something search, instead of thinking about how can I make this efficient or fast or whatnot, what is actually improving the results of what I'm doing, right? And that comes back to our earlier discussion about evaluation. So you actually can quantify, is this better than this? Right? And if you haven't got users and you haven't got the scale, meaning that a lot of query traffic or a lot of documents, you can probably get away with using a more expensive model in any of these dimensions, right? Because you can get the latency down to have a good user experience, right? With this. But as your service becomes more popular, you want to bring in more signals, then you also have interaction data that you can start working on and using to actually use maybe a less resource intensive method, right? So let me be more precise. If you start out with a cross encoder, you can make this work pretty fast today with modern compute and so forth. It's expensive, okay, it is, but you don't have a lot of users at the time, and you can quantify that this is actually improving the result quality by 30%. Then I think you should do that. And then gradually, if your service becomes popular, you have interaction data. You know what people are searching for, you know what they're clicking on, etc. Then you can start looking for cheaper alternatives to kind of distill the knowledge of that expensive model into a more practical thing, right? And that's essentially what Google did and others did as they had to scale out infrastructure. So don't cosplay Google if you're not operating at Google scale, right?
Yeah, and I think that's really interesting because it has become so easy to use really complex model that you now can start out with a more complex application and
Yeah,
then basically slim it down as you gain more experience and more
yeah,
data, which allows you
yeah.
to train more complex stuff.
Yeah. But
Nice.
then again, don't, if you also then it doesn't actually improve the result, then you're just throwing compute and complexity and resources out the
Yeah.
door. So it goes back to having that kind of evaluation. And I think that goes back to also to what I said. My one advice would be to actually take a course in how you actually evaluate these systems.
Yeah. It's like in one or two sentences summarized, have a test set, have a
Yeah.
strong baseline like BM25 and run it against it and see whether it actually gives you a bang for the buck if you introduce
Mhm.
something new.
Yeah.
And in the paper, they also mention creating new representations through the densification of something like inverted indexes, or the opposite, sparsification of dense vectors. Do
Yeah.
you see potential in these approaches or any new research directions that already open that up?
I personally, I'm not that into that because when you get into these details, it's more for me on the details of how you accelerate and reduce the cost of a system. And what we know today is that dense representations and nearest neighbor search algorithms like HNSW, inverted file, there's a ton of them. They have some really good properties in terms of scaling them, meaning at least from the query side compared to sparse representations. We didn't touch so much about sparse representations, but when you're using like a sparse learned representation model like Splade, what essentially it does is to expand both the query and the documents. Yes, there are variants here, but in essence, it expands the query and the document so that you have more tokens of words that have a non-zero weight. That complicates the process of doing accelerated retrieval using the weekend or block-max weekend and so forth over inverted indexes like you will find in both Vespa, Elasticsearch, OpenSearch, and so forth. And they have a little bit different properties in terms of scaling. If they are slower or they are more compute intensive, if they are basically, but if the representations aren't that sparse anymore, right? When you're expanding the sparse representation, so you have an original 3-word query becomes a 56-word query instead, then it's not so fast anymore or compute efficient compared to dense representations. But personally, I love vector search and vector representations because they are flexible, but still we have to keep in mind that using just an off-the-shelf text embedding model might not work that well compared to BM25 in the out-of-domain situation. But I'm really into dense representations, yeah.
Yeah.
And the other great aspects about dense representations is that it's very easy to move them around in space. For example, for personalization and others, you can have adapters on top of these vectors. They are learnable, they're differentiable. Comparing that to a lot of the sparse technologies and sparse methods. Yeah.
Yeah, and one thing we have only tangentially touched at is like actually that you have to match the representations of the query and the documents, which often are in very different like languages or how they are
Yeah.
formulated.
Yeah.
How do cross encoders like Colbert make that easier?
Yeah. So in when we are representing things, we're not longer so let's take the dense representation as an example where you're using a single vector on both ends. So we call those bioencoder or text embedding models. You're not interacting directly with tokens. Like you're not actually matching this token against another token in the document, but you're only interacting through this cosine similarity or dot product in this vector space. So you no longer have token interaction. But in a cross encoder, a model which actually inputs both the query and the document text and all the tokens at the same time, they will have attention on the token level, right? So for each of the tokens in the query, you will have attention to all of the documents token. And that's Colbert model is actually a bioencoder, but it has the interaction late. So it's like a late interaction model where you have token level interactions. And many believe that these token level interactions, even if they're late, they're doing at the scoring time, gives that type of model it generalizes better to new domain or new text. Because let's face it, what you actually typed does matter, right? If you typed Coke, you might want to match a document that has Coke. You might not want to match Pepsi if it has the same similar semantic meaning.
Can you maybe quickly define like the difference between early and late interactions?
Yes, I think late interaction was introduced by the Colbert paper by Omar in the sense that the query and document tokens are not interacting when we are encoding them with the transformer model, right? That enables us to encode the document corpus upfront, offline. So we can encode the document collection, and at query time, which is the late time, we can have that type of interaction using this multiple vector representation. So that's where the late part comes in. But in a more like an early sense would be more like a cross encoder where you're interacting throughout the transformer model with the same inference call, and each of the tokens will interact. Same with when I talk about cross encoders, this also applies to using regular LLMs like rank GPT or things like that, where you're actually using more of a generative model where you basically stuff the prompt with all the documents and ask the model to rank them. There you also have interaction throughout the decoder network between all the tokens. But Colbert enables us to have this kind of interaction with the tokens with neural representations or vector representations.
Yeah, and now moving on to the actual topic of the episode, we discussed ColPali. How does the late interaction model was introduced to like the visual domain in ColPali?
Yeah, so ColPali takes the late interaction scoring mechanisms from the Colbert paper or the Colbert approach and brings that to and combines that with a visual large language model or a visual language model, PoliGemma from Google. So it uses PoliGemma to obtain a multi-vector representation of a screenshot where you essentially take a screenshot of a page, for example, a PDF page, and that page is divided into grid cells. And each of these grid cells are represented as a vector. Like in the text domain with Colbert, you will represent each of the text tokens in the text as a vector. And they are mapped into the same vector space where you're also matching text tokens because it's vision language models. It's combining a vision encoder with language models. So they have learned joint representations of both text and image data. And similar as Colbert, you do the same thing with the query, which is text only, or it could also be an image, but in the ColPali paper, they only touch on you having a text query and you have the document you want to search in. And then you do the late interaction or the MaxSim scoring, which essentially computes a matrix multiplication.
Yeah, and what I was always curious about is I would love to hear your intuition on, is a certain type of language more suited for that retrieval of what you retrieve, that if I have a very like visually descriptive language, that it might have a better chance at retrieving the relevant parts of the document?
By language, what do you mean, German or English, or you mean like inside a particular language? Like
And now really
the
like
tone?
in how I phrase the query, not like what language am I using.
Yeah, I think it's like any system. This will depend heavily on the data that it was trained on. So ColPali is more of a direction. It hasn't been trained on a lot of data, but I see it as the most exciting development in retrieval because when you're building these systems, you're not dealing with these clean pre-processed queries and text like they're given up front. Like in an information retrieval benchmark, you will be dealing with clean text. You will be dealing with some clean queries. Here's a clean document. Is the document relevant or not? But in the industry practitioners, they need to take the documents that they want to search in. They need to convert it into some kind of format, text extraction, whatnot. And maybe then you're doing like this chunk and embed and so forth and vector search and whatnot, which is the whole process is quite complex and error prone. And in a lot of cases, these kind of steps are introducing new errors. You're not extracting all the elements of the documents. You're not extracting the figures. You're not extracting the charts. The layout is totally off. You don't know about like how actually this page is rendered, like with HTML, other types of format. And that's the refreshing thing about ColPali, is that it builds on this development where we have vision language models that have really strong OCR capabilities, that they actually can not just be good at searching for cats or things like that, but they're actually good at looking at text and figures and in documents. And they build on that, and they build on PoliGemma, and they say, okay, what's a good way to take the approach that we saw worked really well for text domain, which is Colbert, and use that with this new capability to do retrieval. And I think it's so refreshing, and that's why I've been so excited about this new type of model.
Yeah. And like the industrial application, I think it also banks on like a vision language model becoming better so we can actually extract the information out of it.
I really recommend people to, if you're not familiar with this, is to use whatever service provider like ChatGPT or whatever of these that allow you to upload an image or something like that and ask questions about. And I think it's like really amazing the progress over the last year. And probably will come at me and say, yeah, but this case didn't work. It didn't extract the text perfectly. But I think there's amazing progress here. And especially around PDFs and complex formats, and it's even HTML, right? Because HTML, it's a mess when you're trying to parse it. You cannot really, you need to render it in order to see actually how it displays and where's the actual text centered. And if you look at relevancy judgments and so forth, if you're actually judging if this HTML document is relevant or not, the user is looking at the screen, like how it's rendered, right? And you might have the position of the text might impact if you think this is relevant or not. So going from this messy text representations, extractions, instead just take a screenshot of the page, feed that through PoliGemma or any other of these vision capable models, and then have a representation which you can use for retrieval. I think that's pretty amazing.
Yeah. And what people tend to forget is like OCR itself, it's so messy. Like extracting information from PDFs always has been messy and also very costly because you tend to extract so much additional stuff from PDFs, which in most cases you don't need. And when you can find it, identify it, and then extract it and use it, whether it's in a batch or a streaming process, it saves you like so much effort.
Yeah. And I also like the aspect that it's in a way how we also as humans, we look at a page, we look at things through our eyes, right? The vision capabilities, and then we interpret this and we take into account the words. So I'm looking right now at the sign, like a stop sign, where I clearly can see cars can't travel here, but there's also text in here. It says doesn't apply to buses or taxis. So there's a whole, both a vision and there's a text there, and ColPali combines these two into one retrieval that you can use for retrieval. Of course, people ask me, yeah, but what's the difference between this and using a vision capable language model like GPT-4? The difference is that for GPT-4, you will have to take the documents and you will upload all the documents and all the screenshots, and then you will ask it the question or whatnot, the information need, right? So it will be more like a cross encoder that we discussed because you will have interaction with this. What ColPali does is that it learns or brings a representation that we can use for retrieval. So let's say we have 1 million PDFs. You might not want to upload that to GPT-4 for every query. This enables you to search across this data, and then you can use a larger model for the kind of re-ranking or extraction phases or question answering, right? In the context of a more like a RAG pipeline.
Yeah. I think it's the same discussion, like RAG versus long context. Like, it's just wasteful and it makes the LLM or VLLM less reliable when I feed in like lots of stuff which likely isn't relevant to the query.
Yeah, but I think it's a good discussion to have Because I think essentially there was a lot of excitement about chat with your PDFs and whatnot. And over the last year, we went from like 8K context lengths to 1 million or 2 million, right? I think it's an important discussion to have. I'm not particularly a fan of the RAG versus fine tuning and whatnot, because I think fine tuning is dead in the sense of large language models. That I see the beauty of them in the capability that they have to follow instructions across so many different types of tasks, right? Instead of dealing with fine tuning, following this recipe, errors, whatnot, just use a capable frontier model. The prices have come down, the context windows are longer. So I think it's an important discussion to be had around this. What actually changes with the increased context window? And it means that you can do a lot more now than you could before, but still there are use cases where you want to retrieve and do a retrieval phase before you start stuffing things into the prompt. Yeah.
Yeah. And maybe to go more into the technical details of ColPali, especially, what is actually the importance of using at the same time page level MaxSim and the cross page MaxSim in ColPali? And can you maybe also quickly touch on MaxSim, what it does and what it is?
Yeah, so let's touch on MaxSim, or the late interaction mechanism. So essentially on the query side, for each of the query tokens, you have one vector, okay? And for each in ColPali, you have one vector representation per what they call grid cell or patch. So the image is divided into cells and you have one vector each. Then you take, for each of the query vectors, you do the dot product with all the patch vectors or grid cells vectors. And then you find the maximum of that query token vector. And then you keep that, you store that, and then you sum and do the same for all the query token vectors and compare them using the max, and then you're summarizing this as the relevancy score, or the score of this document. And ColPali is trained on single screenshots of PDF pages, not documents. So when I did a blog post about ColPali and how to represent ColPali, I flexed a little bit on the capabilities of Vespa, of the tensor framework that will allow you to not only index one document, one Vespa document, one page, but that you can represent the whole document in actually one Vespa document, so that you could actually do interaction not only per page, but you could have interaction across the entire PDF. But I think it might be a mistake by me to introduce all this and flex all the capabilities, because people like, what's going on here? In my upcoming blog post and work on ColPali, I've trimmed it down so that we have actually one page, PDF page is one Vespa document. So to try to reduce the complexity, both in compute and also in actually what's going on there. Yeah.
The one thing like that I had immediately in mind as a limitation of ColPali is actually like, how do I run validations? And especially like in text, I can run factuality checks and stuff like that. But in a visual domain, this is really challenging. What would
Yeah,
you say like on that one?
yeah, I think it's an important aspect. So what the authors did, they used a lot of capable frontier models like GPT, some of the anthropic models that also have vision capabilities, to, when you're retrieving documents and then evaluating, they use a more capable model to say if that actually is relevant. So more like a visual language model as judge process that we already seen becoming quite popular with regular text domain, where you're using a large language models as the judge, as long as you calibrate so forth, calibrate the prompt a little bit so that it aligns with the kind of human preferences. So you need to have a baseline of human preferences, and then you align this. I think you can do the same thing with a vision capable language model. Yeah.
Yeah, and same for like the NLI models. If you have two types of text as input, you can do the same for a text and an image in the end. Would be an interesting trial to do stuff like that. What is a challenge that might arise when you scale ColPali up? Like you have in enterprise settings, you have millions of documents sitting in data lakes. Is this possible right now, or what
Yeah.
would it take to scale it up?
Yeah. So this is definitely possible. And I always get this question, and they ask, will it work for 1 billion documents or something like that? Which goes back to you probably are not building out Google infrastructure right now, right? So I can have ColPali do 1 million documents in my laptop. That's really not but ColPali and Colbert has several orders more of compute compared to a single vector representation, because they are not using just one vector to represent the entire page. It's using multiple vectors. And you're interacting with all the query token vectors. So there's a lot more compute involved in ColPali than a regular one vector representation of the object. So what you would do typically to have low latency is that you parallelize this so that you use more search threads in Vespa per query so that you can get the latency down. But for scaling for a very large corpus, you would need to divide ColPali into two phases. You would have to introduce like a retrieval phase where you're retrieving candidates, and then you can re-rank using ColPali as either the only signal or also in combination with other types of signals that you want to use. And one thing that surprised me a little bit with ColPali and the benchmark that they introduced, the video benchmark, is that even if the text, even if the queries and documents or the documents were like text heavy, they didn't have a lot of figures and so forth, they were still beating, not by a large margin, but beating like very good baselines like BM25, M3, and so forth with chunking and multiple vectors, which is really demonstrating how good or the capabilities of the language models that are paired with vision capabilities. Yeah.
And do you think we can still improve this? Is the
Yeah.
ColPali approach splitting it up? Is it like naive chunking that I'm just going by length? Can we
Mm.
figure out a smarter approach to do that?
Yeah, I'm lucky that I'm not so smart that I'm working on neural network architectures or things like that. But what we can do with CoPoly that we know works pretty well is two things. We can reduce the number of vectors that we represent on the document side. So instead of having 1,000 vectors per PDF page, we might be able to reduce it to 300. And we've tried this in our internal evaluations of ColPali, and also the authors have now tried this, and they don't get the accuracy drop is very small when you, and that's the good thing with having a benchmark or having your own relevancy data set, is that if I do this tweaking, how will it impact the quality? So that's one thing. So then you're essentially reducing the cost by 3x. So if you have a single thread, it's 3 times faster. Then the other thing, and that's something that I've been actively working on over the last week, is to accelerate. So instead of doing a dot product, a floating point dot product, we can instead look at a bitwise Hamming, and we have some interesting results there. And this speeds up the actual process quite a lot compared to float representations. And then you have to go back and then look at, okay, how's that impacting quality? If you're looking at, if in a float range you have the full range of each dimension, but most of them are just around zero. So if you instead represent, if it's positive, you represent it as a bit, which is set or not depending on the float value. And this approximation works really well with Colbert, and it works really well also, it turns out, with ColPali. That's something that I'm excited about sharing more about in the coming weeks, actually.
Nice. I'm really interested in that. How would you actually go about if you come from an industrial setting and you want to apply ColPali in other domains or other data types, like medical images, for example?
Yeah.
What would be necessary to basically fine tune ColPali on a new task?
Yeah, this is a great question. I see ColPali more of a direction of a model snapshot in time that has really demonstrated to us a future direction of retrieval over complex formats. And if you're your domain, if you take the checkpoint that was trained on PDFs and try to apply that to image data of medical or whatnot. That's not going to work. It's going to be like any other technique that you're applying out of domain. They do include like how you actually fine tune, how you go about in the repo that they published. So you will use that, but then you will have to mix it up with training data for your domain, right? So what you're actually trying to solve to train to have a better checkpoint. It's not like a general checkpoint that will work across a lot of different domains, but I see it personally as a fantastic direction of retrieval over these complex document formats.
Yeah. I think especially the medical use cases you can do with that are really interesting. Also, satellite images are interesting to approach with this. What are some of the more interesting use cases you've already seen implemented or you have tried yourself?
Yeah, so personally, I only looked at the checkpoint and the model that the intended use, and it's been trained on PDF. So that's what my focus has been on. But I think this approach is promising for also for web search for HTML because it's also a format that needs rendering to actually see what's going on. You avoid things like some of the text is hidden for CEO, spam, whatnot. You don't have the menu items. You can put weight into what's actually in the center of the page. Yeah, in summary, all kinds of complex formats that are really needs to be rendered or printed. I think that's where ColPali will shine.
Yeah. And I think we're starting to close out right now. What I always ask is basically overrated, underrated. What's an underrated technology? What's an overrated technology at the moment?
Personally, if we go underrated, meaning that is underhyped, I would say baseline BM25. Okay, that's a good starting point for a lot of different retrieval aspects. So I think that's underrated. Overrated in terms of retrieval, I think some of the 7 billion parameter embedding models that are zero point 0.2 NGCG points ahead of a much, much smaller model with some much, much smaller dimensionality is overrated. Yeah.
And what is actually something that you would love to see built in Retrieval or around it? What would actually make your life way easier, especially?
Oh, I think ColPali would be fantastic to see more model checkpoints, larger interest in the community because it eliminates so many of the pain points around indexing, extraction that I really would like to see more like ColPali oriented models. We see now more and more vision capable language models. There is also 5 from Microsoft, 3.5 with Vision Instruct with long sequences. I love to see someone use that to build Fi or things like that. Yeah, I really believe in that direction. So I'm hoping to see more of that because it avoids so much complexity on the document processing side.
Yeah. And what's next for you? What's next at Vespa? What can you teaser?
Personally, I'm so excited about ColPali that I'm all in on ColPali, and I also all in on how do we accelerate MaxSim and late interaction. How can I touch on these questions that you brought on terms of scaling? What does it mean that we have this amount of vectors? How can we accelerate that? How can we make it practical? How can we make it work with 1 million documents? How can we make it work with 1 billion documents and so forth? Because I got a lot of questions around this. So that's a near term. And I also think there's raised awareness now that a single vector model that you represent the entire object with a single vector is not the greatest representation, that there are multiple aspects of a document and these kind of hybrid capabilities of Vespa. So that's something on the Vespa side that we are still investing a lot in, bringing this together into one platform. So you can start with BM25 with Vespa, and then you can move on to more advanced cases as your knowledge and also your evaluation strategies and so forth increases. Then you can actually start exploring with more kind of fancier techniques, if you can call it that.
Yeah. And if people want to start building the stuff we just talked about, where would you point them?
I would, well, I'm biased, of course, but I would like them to go to blog Vespa AI and read some of my blog posts, maybe check out some of the tutorials or the Python notebooks that we've done, hang out on Slack, and yell at me at Twitter. I'm quite active on X or Twitter, so you can yell at me there.
Okay, what can we take away? I think the excitement of having AI that can navigate and look at documents and web pages and whatever more like a human is very interesting. And we are basically moving away from having a large pre-processing pipeline for every type of document, but rather using something like ColPali to find the relevant information, and then either using a VLM to get the information or immediately answer questions about it, or run the post-processing or the extraction pipeline only on the relevant parts, which, especially if you have large copy of documents, will save you a lot of time. And to make it a little bit more tangible, like what could you use this for? What I'm at the moment working on is using it for especially annual report, so long financial documents where you have a lot of graphs, a lot of tables, but also a lot of text. And most of the time, for me, the interesting information is rather hidden in one of the table or one of the graphs and not in the text. So I basically need to find them and then extract the information. But because in an annual report, there are often like 20 different tables, at least, for different types of information. So I basically want to identify the relevant table and then basically extract the table, post-process it, and use it further down the road. And I think you can apply that to a lot of different areas. So for example, medical records, government reports, but also legal documents, academic papers. I have like a whole list of those. Product catalogs, technical manuals, like everywhere where you have a mix of images, tables, text, you might be better off using something like ColPali, especially down the road as the vision language models get better, and not doing all documented extraction. But at the same time, when you have like predominantly text and the information you need in your application is in the text, you should probably stick with the current paradigm and run an extraction, because text extraction with something like AWS text extract, it's pretty good. One more exciting area is something Scott Belsky, the chief, I'm not sure what's his position, but he's at Adobe, mentioned, is basically having a better onboarding experience for software products. And I think using something like ColPali and vision language models could be very interesting for that, because these models are basically looking at the software products like a human would. So they might be more interesting for actually demonstrating the different use cases and especially answering specific questions the user has or guiding him to the specific target. And why I think this is relevant, because most often in software, it's important when he signs up to the product to get him to his target as fast as possible or to value as fast as possible. And when you can guide him specifically on the goal he has, this could be very interesting. But yeah, so for now, I think like ColPali has so much potential. Whether it's already there in terms of like applying it as embedding models are, I don't think so, because embedding models are pretty optimized already. Like you have so many different indices which optimize for the retrieval, and ColPali doesn't have that yet. They're already working on it, like especially you at Vespa with his bitwise Hemming, but we will probably see so much development that probably in like the next few months we will see like some form of efficient computation over ColPali embeddings and an efficient storage. And yeah, I'm excited for it. If you want to try out like any of the things, or if you have an idea and want to get my feedback, just hit me up on LinkedIn, on Twitter, wherever. And yeah, I'm really excited. I will probably share some guides of what I'm doing. Maybe do a demo with ColPali of how I would use it. Maybe for cookbooks even, or something like that.